Picture a developer debugging a broken deployment at midnight. They add one quick line echo the database password to the log just to confirm the variable is set. GitHub Actions masks it with 3 asterisks, and they breathe a sigh of relief. But masking is not a safety net, it is a last resort. Short secrets slip through. Base 64 encoded values are invisible to the scanner. Error messages from third-party tools echo credentials in formats GitHub has never seen. The only real protection is never letting the secret near the log in the first place, and that means understanding GitHub's secrets model from the ground up. Secrets in GitHub Actions are encrypted key-value pairs stored inside GitHub's infrastructure, never persisted in plaintext anywhere in the system. When you save a secret, GitHub encrypts it immediately using a libsodium sealed box. From that moment on, not even GitHub staff can read the raw value back. During a workflow run, the runner decrypts the secret in memory and injects it as an environment variable available to your steps. Once the run completes, the in-memory value is gone. The lifecycle is deliberate: store once, use transiently, never expose, and it all happens automatically. GitHub gives you 3 levels of scope to match how broadly a credential needs to be shared. Organization secrets sit at the top, a Slack webhook or shared NPM token that every repository in your org needs. Repository secrets are scoped to a single repo, perfect for a Docker Hub token that only this project uses. Environment secrets are the most precise, they exist only when a workflow deploys to a named environment like production, so your production database password never leaks into a staging run. Start with the narrowest scope that satisfies your needs and expand only when required. Creating a repository secret takes 4 clicks in the GitHub UI. Navigate to your repository, open Settings, find Secrets and Variables under Actions, and click New Repository Secret. You give it a name, by convention all uppercase with underscores, like db_password, and paste the value. The moment you save, the value disappears from the UI forever. You can update or delete it, but never read it back. Names must be alphanumeric with underscores, cannot start with GitHub underscore because that prefix is reserved for built-in variables, and values can be up to 48 kilobytes. In your workflow YAML you access secrets through the secrets context written as secrets. Followed by the secret name inside the double curly expression syntax. There are 2 safe patterns for getting that value into your steps. The first is passing it directly to an actions with block, as you would with a Docker login action receiving your registry token. The second is mapping it into an env block scoped to a step, which exposes it as an environment variable that your shell script reads by name. What you must never do is interpolate a secret directly into a run command as a positional argument. The value ends up in the process list, visible to other processes on the runner. GitHub provides 2 sibling stores, vars for configuration values and secrets for credentials, and the distinction matters enormously. Variables stored in vars are plain text, they appear in the UI, show up in logs, and are appropriate for things like an API base URL, a node version, or a feature flag name. Secrets are encrypted and masked, use them for anything that grants access: passwords, tokens, private keys, and connection strings. A useful heuristic: if you would be comfortable writing the value in a public README, it belongs in vars. If exposure would compromise a system, it belongs in secrets. Using the right store for each piece of data keeps your workflows readable without sacrificing security. GitHub Actions implements secret masking at the runner level. Before any logline is uploaded to GitHub servers, the runner scans the raw bytes of every output stream and replaces any substring that matches a registered secret with 3 asterisks. This happens transparently, with 0 configuration required on your part. The effect is dramatic: a database password that would have appeared in plain text in the log simply shows as 3 stars, protecting it from anyone who views the run output. But understanding that masking is a reactive filter, not a preventative barrier, is what separates developers who build genuinely secure pipelines from those who rely on it as a safety blanket. The echo trap catches experienced developers too. GitHub's masking engine has documented limitations. Secrets under 3 characters are never masked because they appear too frequently in normal output and would make logs unreadable. If you pipe a secret through base 64 or any other encoding, the transformed string does not match the registered value and passes through the mask entirely. Tools like curl sometimes echo the full URL including embedded credentials in their error output, in a format the scanner does not recognize. The mental model to internalize is this: a secret should flow from the secret's context directly into the tool that consumes it, in a single step, without any intermediate transformation or inspection. Environment variables in GitHub Actions workflows follow a clear 3-tier hierarchy. At the top of your workflow YAML file you can define a workflow-level env block. These variables are available to every job and every step in the file, making them ideal for global defaults. At the job level you can define an env block that applies to all steps within that job, useful when a group of deployment steps needs a shared configuration. Finally, individual steps can declare their own env block, which overrides both job and workflow level for that step alone. The rule is simple: the narrowest scope wins. Use this hierarchy intentionally, set sane defaults at the workflow level and tighten constraints closer to the steps that need them. Every workflow run receives a special secret called GitHub_token automatically. You never create it, rotate it, or clean it up. GitHub mints a fresh token for each run, scoped exclusively to the repository executing the workflow, and revokes it the moment the run completes. This token is what allows your workflow to push commits, create releases, post comments on pull requests, and call the GitHub REST and GraphQL APIs, all without you managing a personal access token. Because it is ephemeral and repository scoped, GitHub_token is inherently safer than a long-lived personal token. It is the right tool for the vast majority of within-repo automation tasks. By default, GitHub_token carries broad permissions, which violates the principle of least privilege. GitHub lets you restrict those permissions with a permissions key either at the workflow level or the job level. Setting permissions to an empty block at the workflow level denies everything, and then each job explicitly requests only what it needs. A job that reads source code and pushes a Docker image to GitHub Container Registry needs contents read in packages write, nothing more. A job that comments on pull requests needs pull requests write but likely nothing else. Granular permissions mean that if a malicious action is introduced into your workflow, it cannot perform actions beyond the narrow scope you authorized. Secrets are not set and forget artifacts, they have lifespans. Platform-issued tokens expire on schedules that do not align with your deployment calendar. Long-lived credentials are higher-value targets for attackers who have time to try them. When a team member with access to your CI system leaves the organization, any credential they could have observed should be considered compromised and rotated immediately. GitHub CLI and REST API make rotation straightforward. Generate the new credential in your external system first, update the secret in GitHub using the ghsecretset command or the API endpoint, then revoke the old credential. Because the new value is injected at workflow start time, in-flight runs complete with the old credential while new runs use the fresh one. Zero downtime. Git is an append-only log, and a secret committed even once lives in that log forever, in every clone, every fork, every mirror, and every archive ever created from that repository. Deleting the file and pushing a new commit does not help. The secret is retrievable with a single git log command. The correct pattern is a two-file convention, a .env.example file committed to the repository containing placeholder values that document what variables are needed, and an actual .env file containing real values that is listed in .gitignore and never touches version control. In a CI context, real values belong only in GitHub's encrypted secret store, fetched by the runner at runtime and never written to disk in the workspace. Time to apply what we have covered. You have a multi-environment deployment pipeline. The same workflow runs for both staging and production, but the database passwords are completely different. A repository secret would be available to both environments with no way to distinguish. An organization secret would be even broader. A workflow-level environment variable would be committed to the YAML file in plain text. The correct answer is an environment secret, scoped specifically to the production environment. When the workflow runs a job targeting the production environment, GitHub injects the production credentials. When the same workflow runs against staging, those secrets are simply unavailable, exactly the isolation model you need for safe multi-environment deployments.